In this video, we're going to talk about vector operations. So if we have vector v in U that has a sub 1 and b sub 1 and a sub 2 and b sub 2 respectively, and we have k that is a real number, then we have these three operations. So the first one we're going to talk about is the scalar multiplication. So a scalar multiplication says that if you take a number and you multiply that vector by that number, essentially all you're going to do is distribute that number to each part of the vector. So off to the side, if we come up with our own example, so if we have 4 times vector 3, -5, all we're going to do is distribute that 4 and do 4 times 3, which is 12. And then we distribute that 4 to the -5, which is -20. And that would be our new vector that has been multiplied by 4. We have vector addition. Vector addition just basically says that if you have two vectors, v plus w, then you can add the first two terms together of each vector and then the second two terms together of each vector. So if we go and we create ourselves an example, if we have 2, 3, and we want to add 5, 8 to it, all we're going to do to get our new vector is I'm going to add the first two terms together. So 2 plus 5, 2 plus 5 is 7. Then I'm going to add the second two terms together, which is 3 plus 8. 3 plus 8 is 11. And that would be my new vector right there. Then we have vector subtraction. So if we are subtracting two vectors, then we subtract whichever vector comes first minus the second vector for both terms. So it does matter for this the order in which we subtract. So if I use those same numbers that I had above, 2, 3, but this time we're subtracting, then we're going to subtract 2 minus 5. 2 minus 5 is -3. Then we're going to subtract 3 minus 8. 3 minus 8 is -5. And that would be our answer right there. It is important that with subtraction, you make sure you are subtracting in the correct order, whereas addition, it does not matter the order in which you add. Okay, so in example 1, we're going to let vector v be 1, 2, and vector u be 3, 1. And we want to find vector v plus vector u. So what we're going to do is since we're adding vector v plus vector u, we're just going to go ahead and add. So remember, we're going to do 1 plus 3. 1 plus 3 is 4. Then I'm going to add 2 plus 1, and that gives me 3. And that would be my solution to vector v plus vector u. Now, we do have a graphical way to represent that two vectors being added. So if I show you graphically how to add vector v and vector u, it's going to look like the following. So the first method is called the tip to tail method. Remember that the tip comes from the terminal side, so the side with the arrow. And the tail comes from the initial side, the place where we start. So if I wanted to add vector v and vector u, how we using the tip to tail method, what I'm going to do is I'm going to start at 0, 0, and I'm going to draw vector v, which is from 0, 0 at 1, 2. So it's going to be this line right here. Or that vector right there. So that right there represents vector v. If I am going to add vector u, I am going to start at the tip of vector v. So the tip of vector v is this right here where the arrow is. It is the terminal side. This is the tail. This is the tip. So if I'm going to add vector u, that's at, so I'm not going to plot it at 3, 1. What I have to understand is to get to 3, 1, so that point right there, I go up 1 over 3. So from the tip, I'm going to go up 1 over 3 spaces. And I'm going to put a point there, and that is where I'm going to add vector u. So if you notice, that's vector u right there. Okay, so what I want you to see is that if I go from the tail of vector v to the tip of vector u, it makes a new vector. Well, that new vector is v plus u. Notice where that new vector ended at. That new vector ended at 4, 3, which is what we got when we added them, which is normal addition. So it's showing you that you can add them graphically, and what I have in green, when it leads you to that last spot, that is where your answer is. So what I have highlighted in green. Same concept would have worked if we did u plus v. U plus v would get us the same graph, and that is what we call the tip to tail method. It is very important that when you draw the green line, the solution line, that you have the arrow going towards that new component form spot. So like I have it here. The second method we have is the parallelogram method. The parallelogram method is a method that shows you that you can add or in either direction and you get the same thing. This time we should be making a parallelogram. So what happens is that we're going to start by graphing vector v from the origin. So vector v was 1, 2. So it's going to go to right here. Then I'm going to have vector, sorry, that line wasn't very good. Then I'm going to have vector u, and I'm going to graph that one from the origin at 3, 1. Okay, so what we need to do is we need to make a parallelogram out of this. So how we're going to do this is we are going to graph, let me go ahead and label these real quick. So 1, 2 was vector v. So this one right here is vector v. And this one right here is vector u. So what we can do here is I can add u to v and then v to u. So same concept. I'm going to start, and I'm going to change my line to a dotted line so you can see it right there. So if I add, it's going to go right there. And then if I add v to u, it's going to end up right there. And notice how it makes a parallelogram. So this is something that you will see on your test. But what you're looking for and how you know the correct answer from one that is not the correct answer is that you have the answer going from the origin to that new component form right here, and it's going in the correct direction. So you don't want it going towards the origin, you want it going towards that new component form. And that is the parallelogram method. So you just need to make sure that when you're asked to do the parallelogram method, that it looks like a parallelogram and that the solution goes from the origin to that component form. So now we have example 2, where we have 3 different vectors. Go ahead and pause the video and see if you can answer these questions, and then check your answers with the video. So if we're doing example A, what this means is we are taking 2 and we are multiplying it times vector C. Well, vector C is -4, 5. And so all we're going to do is we are going to distribute that 2 to the -4. When we do that, we get -8. Then I'm going to distribute that 2 to the 5. When we do that, we get 10. And then we go ahead and put our vector brackets on it. And that is our answer, -8, 10. Looking at B, we want to add vector A to vector B. So vector A is -6, 2. And we're adding 1, 7 to it. So all we're going to do is we are going to take the first number and the first number, and we're going to add them together. So looks like I messed up my blue. There we go. -6 plus 1. -6 plus 1. That is a -5. Then I'm going to add the second 2 numbers together. 2 plus 7. 2 plus 7 is 9. And there is our solution vector. Going on to C. So in C, notice that we have a scalar out in front of A, and we have a scalar out in front of C. So I need to multiply A by 1/2. Then I need to multiply C by 3, and I can add them together. So A is -6, 2 plus 3 times C, which is -4, 5. I'm going to go ahead and distribute my 1/2 to -6. So 1/2 times -6 is a -3. Then I'm going to do 1/2 times 2. Half of 2 is 1. So there is that vector for us. Then I'm going to add when I distribute 3. So 3 times -4 is -12. 3 times 5 is 15. Now that I've taken care of the scalar multiplication, I can do the addition. So I have -3 plus -12. -3 plus -12, that makes a -15. And then lastly, we have 1 plus 15, which gives us 16. And that would be our solution vector to 1/2 vector A plus 3 vector C. Looking at letter D. So this time we need to multiply by a 2, and we're subtracting. So I'm going to highlight both of those so we can see. So vector C gets to stay the same. It's going to stay -4, 5. Then I am going to subtract when I multiply 2 by vector V. So let me write the 2. Actually, let me write those like that. There we go. So vector B is 1, 7. So I'm going to distribute the 2. Let me write the minus sign in a different color. That way we don't think that they're the same thing. And then I can change this color as well. Boom. Let me fix that. There we go. So this one right here is going to stay the same. The minus sign can drop down. And I'm going to distribute the -2. So, sorry, not -2, the 2. 2 times 1 is 2. 2 times 7 is 14. Now I'm just going to go ahead and add. So when I add the first terms together, subtract -4 minus 2, -4 minus 2, which is -6. 5 minus 14. 5 minus 14 is -9. And that would be our solution vector. So that is vector operations. Now, the next thing we need to talk about is an equivalent way of writing a vector into trig form. This is going to help us when we talk about applications with vectors and bearings. So any vector can be written in the trig form, where we have vector V can be written as the magnitude of vector V times cosine theta, which is the direction angle, and the magnitude of V times sine of theta, which is the direction angle. So once again, this right here, remember that means the magnitude. So let me write that out. And theta is the direction angle. So remember, when it is in the first quadrant, that is the only time that the calculator gives us the correct answer. After that, we have to make sure we either add 180 for the second and third quadrant or add 360 for the fourth quadrant. So we want to write each vector in trig form. So we have vector A. Vector A has 15, 8. So what we need to know and what's going to help us first is when we know it's in the first quadrant. Okay, so we're going to start by finding the magnitude. So step 1, we're going to find the magnitude of vector A. So that is where we take the square root of 15 squared plus 8 squared. 15 squared plus 8 squared is 289. So before you do anything, you need to make sure that that is not a perfect square. So what I mean by that is when you type this into the calculator, so if you weren't sure, 15 squared plus 8 squared, we get 289. Before you do anything else, you check to see if it's a perfect square. If it's a perfect square, then you don't have to do any simplifying of the radical. The answer is just 17. So that was a perfect square, and it's just 17. So the magnitude for vector A is 17. Now comes step 2. Step 2, we find the direction angle. Remember, we already said that it was in quadrant 1. So to find the direction angle, we take tan theta of B over A, so 8 over 15. And then in our calculator, we're going to type in tan inverse of 8 over 15. And because it's in the first quadrant, because 15 and 8 are both positive, then the answer we get is the correct answer. So when you go to your calculator, you need to make sure that you are in degree mode. So I check my angles in degree. I can do tan inverse of 8 over 15. And it gives me 28.07. So we're going to round to 2 decimal places, 28.07. Okay, so what we just found is the magnitude and the direction angle. Now that we know this, we can write this into trig form. So to rewrite this into trig form, we're going to start with the magnitude of 17. Let me fix that. Times cosine, because cosine is x, of our angle, which we got to be 28.07. And just to be safe, I'm going to put parentheses around that. It's not needed, but again, just so you can see the separation. And then we do the magnitude times sine of our direction angle, which is 28.07. And that is how you write the vector 15, 8 in trig form. Remember, cosine is x, sine is y, so that should be familiar to us. Going on to the next one, vector, or part B, where we have vector r, which is -2, 2. So first thing we do is we look to see, or we find the magnitude. So I'm going to start with the magnitude first. The magnitude of r is equal to the square root. Remember, when you're squaring a negative number, it needs to go in parentheses. If you just want to make a habit and always put everything in parentheses, that is going to be better for you. So when I do that, I get 8. Before we do anything, we check to see if this is perfect, especially if you don't know your perfect squares. So I have the square root of 8. I get a decimal, therefore it is not perfect. So we want to go to a graph. We're going to type in the number under the radical. We're going to divide it by x squared. I'm going to press enter, and then we want the table. You hit Control T. What we're looking for is to see if anything simplifies. Well, I see right here it simplifies, so that means I get 2 rad 2. 2 rad 2. So the square root of 8 simplifies to 2 rad 2. Well, if you think about it, it simplifies to 2 times 4, and then 2 times 2. If you have a pair of 2's, they get to leave. If you don't have a pair, it stays on the inside. So you always have that method, but please don't forget to check for a perfect square first. So there is our magnitude. Next, we need to find our direction angle. So step 2 is our direction angle. So before we do anything, we see that x is negative, and when x is negative and y is positive, that means we're in quadrant 2, which means the answer we get in our calculator is not going to be our answer. We're going to have to remember to add 180 because it's in quadrant 2. So we have tan theta is equal to positive 2 over negative 2. So in our calculator, we're going to type in tan inverse, and let's see, we get -1. Oh, not -1. I mean, you could write -1, yes, but I'm going to write 2 over -2 just to keep it consistent. So now we can type it in the calculator. And remember, you have to add 180 to get theta. You have to add 180 to get your theta. So I go to our calculator. I'm going to go get a new calculator. I do tan inverse of 2 over -2. It gives me -45. That is not my answer. I have to add 180. When I add 180, I get 135. That angle falls within the second quadrant. That is my answer. 135 degrees. And I will need that to write my vector into trig form. So now that we've done that, we can go ahead and write our answer out. Remember, cosine goes first, sine goes second. So I have my magnitude of 2 rad 2 times cosine of my angle, which is 135. Then I can go to my second term, which is sine. So again, I start with my magnitude of my angle and that is the, let me fix that, that is the trig form of the vector -2, 2. Okay, you don't need to do anything more because remember, if you simplify it, it's going to give you what you started with. You would be undoing everything we just worked to get. So this part, you're just watching. You're not touching a calculator. You're not doing anything. You are just watching. You're not writing this down. You're watching. If I go back to, I'll do part B. If I tried to type in, okay, 2, let's see, 2 rad 2 times cosine of 135, it gives me -2. If I do 2 rad 2 times sine of 135, it gives me 2. So I'm showing you that if you try to do anything from this point, it's just going to get you back where we started and you just undid everything that we worked for. You can do this to check your work, and that's it. Only to check your work. Looking at our last example, find the component form of each vector with the given magnitude and direction angle. So this time, we're given the magnitude, we're given the direction angle, and now we have to find the component form. So now we will be evaluating. So I'm going to write it in the trig form. So this is my magnitude. This is my direction angle. And so what we get is 8 times cosine of 60 degrees. And then we have 8 times sine of 60 degrees. And so now we work on evaluating. So what do we know? Well, we had a whole unit where we focused on the unit circle, and we should know sine of 60. Sine of 60 means you're putting down your index finger, cosine of 60 means you're putting down your index finger and it's on top. We have one finger, so that means it's going to be 1/2. So we have 8 times 1/2. Then the same concept, I put down my index finger, but it's sine, so it's the 3 fingers on bottom, which means it is rad 3 over 2. If I multiply these out now, 8 times 1/2 is 4. 8 times rad 3 over 2. Well, this 2 simplifies the 8 into a 4. It divides it by 2. So we get 4 rad 3. And that would be our answer. Looking at our last example, if you want to pause the video and give it a try, do so now. So we're given our magnitude right here. We're given our direction angle. Something I forgot to point out in A is that 60 degrees is in quadrant 1. If we look, both of our signs are positive, so therefore it is in quadrant 1. Looking here, 225 we should know is in quadrant 3. So my sine and my cosine, or my x and my y value of my component form, or my a and my b value, should both end up negative. So here we go. We have 20 times cosine of our angle, direction angle, 225. Then we have 20 times sine of our direction angle, 225. So when we evaluate this, we should know that 225 corresponds to the 45-degree reference angle. So that would be the middle finger down, which leaves us with 2 fingers on top. So we get a negative rad 2 over 2. It's negative because it is in the 3rd quadrant. So same concept over here, the middle finger's down, sine of 225 is negative rad 2 over 2, because again, it is in the 3rd quadrant. Let me fix those. So I multiply, same concept with the simplification. The 20 and the 2 cancel out, and this gives me a 10. So I have a 10 times a negative rad 2, which is negative 10 rad 2. Same thing over here, that cancels that out, and we get left with 10. So again, negative 10 rad 2. And if you wanted to check your answer, you could type in cosine 225 and see that it matches negative 10 rad 2. So what I mean is if you do 20 cosine of 225, you get that decimal. If I type in 10 times rad 2, negative 10 times rad 2, I get the same decimal. And so if it matches for sine, then we should be good. But if you wanted to double check, you could always type in and see that we get the same decimal. Okay? So that is it for vector operations and writing our vectors into trig form. If you have any questions, please write them down at the bottom of the page and make sure you ask the next time you're in class.